we have a very special guest. This is one of the spontaneous friends I met in LA, and now both of us are not in LA anymore. But such a smart dude, such a great dude. Jordan Crolly, energy engineer. What's up, man?
Right. What's up, Jerry? Good to see you, buddy.
Wow, so much to talk about, so much to learn from you.
Yes,
Now,
sir.
let's talk about the whole path you took. Did you know you were going to be an engineer? Was that always the path you knew you were going to do?
Well, I got interested in sustainability in high school, actually,
Mm-hmm.
in renewable energy and in particular in high school in 10th grade. So I can tell that story if you're interested in that. But that eventually led me to wanting to go to Penn State. And what originally, when I went there, I was planning to do electrical engineering, mostly because I knew I wanted to do renewables, but I didn't really know like how to even get into that because this was like 2008 at the time and wasn't really much of a market, an industry at the time. And when I went there for orientation, I found out that they had an energy engineering program.
Ooh.
It was brand new. She warned me, the person that was helping us there, she warned me that it was not yet accredited. And I was like, I don't care. I'm in, no risk it, no biscuit.
Yeah.
And I had no regrets. And by the time I had graduated, it had been accredited. And I was one of the first classes to graduate in that program. Not the first, but one of the first. And then after that, I had and we can slow this down and unpack this as much as you want. But after that, I had a job in Michigan. But I decided that I was going to go to school part-time while I was working full-time.
Oh, I didn't know that part. Wow.
Yes. So I went to Penn State's World Campus. So it's just online, which was also a brand new program. And that was in renewable energy and sustainability systems. It was a master's of interdisciplinary studies. They pack a lot of words in there to make it sound really cool, but that was focused on solar, but it was really broad in terms of energy generation technologies and policy and planning pieces too.
Wow. Let's go to the inception in high school. What was the moment like when you decided I want to look into this?
It was kind of a lot of fun. I kind of love telling the story actually. And I've told it in interviews in the past, and it's kind of like, it's a long time ago now. So it kind of feels weird sometimes telling a story from high school, but it was kind of a pivotal moment. So there was a few different things that kind of came together actually. It was around 2005, 2006, in that time range. I was in 10th grade. And this is the same time period where Hurricane Katrina had happened. Right. So through Hurricane Katrina, I saw a couple things. I saw gas prices go from like $2 a gallon to like $5 a gallon in like a couple days. And I was like, wow, like this is crazy that our energy system is this sensitive to the environment, basically storms. Right. So like, that's interesting. Kind of made me perk my ears up a little bit. But then, also you have the devastating loss of life and loss of infrastructure and just the damage that those storms created, which are linked to climate change. Whether that's true or not, I'm not here to debate that, but it's certainly what I believed and what I still kind of believe, that these are getting worse because of these things anyway, So I was like, this is interesting, right? So then I started getting into it. I was into I was interested in biofuels. I was interested in wind power. And then that same year, 10th grade, we had an American government class. And in that class, we had a mock Congress. Have you ever done one of these in your school?
Yes, I remember mock Congress and AP
Yes.
government. I remember that.
Yes. So the basic assignment was, here's a list of all of the tax cuts and spending increases or whatever that we're going to put into this year's budget. And your job was to balance the budget, right? So your first task was to go home by yourself as an individual, check what boxes you want to check and leave the other ones unchecked, right? So there was things on there you might expect, like defund Planned Parenthood for X $million. There was reduce military funding for Y $1 million. There was, a tobacco tax, an alcohol tax, maybe 50 different things on the list, something like that, right? And maybe the average was about $1 million a piece, right? But one of the items on there was like $100 million item, and that was a gasoline tax. So I was like, interesting. First of all, it's a huge ticket. And I kind of had the intuition that, hey, okay, so people aren't going to be necessarily thrilled with this gasoline tax because it's obviously going to make gasoline more expensive. But by making gasoline more expensive, what that does is it indirectly incentivizes folks to do alternative energy, whether that's biofuels or electric cars or whatever, to explore alternatives, right? And it's going to kind of like a soft incentive to move them away from this and explore other opportunities. So I'm like, yes, let's check this box, right? So I come to school the next day, my 25-person class, whatever. I was the only person in my class to have checked that specific box, to think that was a good idea, okay? So I was like, all right, bet. So we get in our little groups, and you'd have to choose whether you're going to be a member of the House or a member of the Senate, and then whether you're going to be a Democrat or Republican, and what state you're going to represent. So I chose to be a Democratic senator from the state of Wyoming, which I actually looked up recently, like isn't really a thing. Like there hasn't been one of those in like a very long time, right? Like that's a very rare thing. So I was already in uncharted waters there, right? So you get with your group. So you have to meet with your fellow senators, you have to meet with your fellow Democrats, and you have to kind of try to come to a joint resolution for like what you all want to do as a bill, right? So I'm the only person that has this on my list. And in the 45-minute class period, I can't get anybody to join my side, right? No Democrats, no senators, nobody wants to do the gasoline tax. But I had conviction, Jerry. I knew I was right on this. You know what I mean? I knew it was a good idea, and I knew renewable energy was coming, and I knew it was going to be part of the future. And I knew that this was even though it was make believe, this was the right move if we were going to move in that direction, right? So instead of just limiting it to the classroom, I went outside the classroom. I went to different people's lunch tables, and I sat with them. I brought in books on wind power and biofuels, and I talked to them about, hey, this is why we need to do the gasoline tax. I was on the bus, like talking to people on the bus, right? I'm at practice after school, talking to people at practice. I'm at parties in the woods on like Friday night, drinking beer out in the woods, talking about the gasoline tax. And people were like, Jordan, enough is enough already, you know? But whether they agree with me or whether I wore them down or whatever, eventually I got enough people to support it to get it on our class bill. And I was like, damn, that was a lot of fun. Like, I think, you know, I learned a lot. I was able to persuade people to my side. Like, this is a very interesting thing, and I want to get involved in this. You know, it kind of was like it all clicked. I'm like, damn, I'm good at this. This is fun. I like this. I believe in it. Like, let's get after it. And like from that point forward, I was into it. You know, I did a couple different science projects when I was in high school. I built a little wind turbine out of like a water bottle. You cut the water bottle in half, and it like spins. It's like a vertical axis wind turbine. They're very cool, fun little project you can do sometime. I built I bought a little generator thing that attaches to a bike wheel. So you pedal the bike and it spins a little generator, and you can measure how much power you can generate from that. So I was playing with that, and I was just interested in all those things. And Penn State was actually the only school I applied to. I pretty much knew I would get in, even at least at a branch campus, a satellite campus, right? And once I knew that I had the energy engineering program, I was like, this is where I'm supposed to be. This is what I'm supposed to do. And they had this really cool project. Penn State had this really cool project that I was interested in getting involved in. It was called the Solar Decathlon. They had participated in it a few times, I think, where the students, with help from professors and faculty and industry sponsors, they build a little solar-powered home or wind-powered, solar-powered home that's kind of uses all these eco-friendly materials and uses passive solar design and all this stuff. And I was like, I want to do that, you know? So I got really excited about that. And by the time I got to Penn State, they were kind of winding that down. So I didn't really get involved in that. But I got involved in a bunch of other on-campus, clubs, student-led organizations, took on leadership roles there, got project experience, like built a name for myself, like really learned a lot through that, and was actually able to kind of parlay that experience into an internship with the school, working in their energy engineering department. And you know, by the time I graduated, I was given tours of that same Solar Decathlon home on the sustainability center there. They planted a tree for me in my honor as like a student sustainability leadership award there on campus. That's still one of my proudest moments to get that award. And I go back and visit my tree anytime I make the pilgrimage back to Penn State. So
wow.
Yeah.
Wow. Sir. So one of the things that I can tell just listening to you now is you are able to know which leaps of faiths to take that kind of ultimately pay off, right? And obviously we can say without a doubt some of it's luck, but obviously you saw something. Saw something. So what would you give advice for people who might want to take some kind of leap of faith, but you know, it's like, what was in your thought process? What made you decide to lean that one way?
Yeah. Well, I was passionate about the sustainability side of it, the environmental side of it. I also knew that energy is big business, and that if I had expertise in energy, that I would probably have a, some what do they call it? Job certainty, right, or whatever that's called, right? I knew there would be a role for me somewhere if I built the expertise in that subject and got involved and took the chances on myself, that it would pay off in some way, and it certainly has.
Yeah, I guess so. One is you did some market research. You had more knowledge of the potential marketplace, right? Even knowing the potential marketplace is huge. And then passion on top of that. I mean, those are two big things. Like, funny story, right? When I started fight commentary breakdowns, I'm like, every person likes to think they can fight. And I have the passion. I think I can build a brand on that, right? It's sort of a similar thing. Like, how many people 20 years ago would have thought, oh, wow, like, just having a YouTube channel. What is a YouTube channel? But if they knew I have a YouTube channel, I'm like commentating fights. What the heck, you know? Right. So so very equivalent how we like both went about our stuff.
Totally. Yeah, 20 years ago, saying I was 15, now I'm 35. I bet on myself in renewable energy. If I had done the same thing with YouTube or whatever, it would have went a complete different direction. But there's certainly opportunity there to be successful.
Yeah, exactly. So. Okay, so now you're in Michigan, right? You're in Michigan and you're taking classes and working at the same time?
Oh, yeah. So, not now, but that's where our story left off, right? So that's 2013. I had graduated from Penn State, moved to Michigan. I didn't have a car. I didn't know anybody in Michigan. I had no friends there. I had my friend take me in his truck and they dropped me off there in Michigan. I bought a bicycle from the local bike shop, made friends with the people at the bike shop, and started riding my bike to work in Michigan, where I worked for an electrical contractor as part of their renewable energy division. So I was a little bit of like a round peg in a square hole there, because they hired a lot of electricians. They hired a lot of project estimators, project managers, where I was coming in with like this energy engineering background. But I had made such a strong impression with some of the owners of that company at a conference that they wanted to bring me on the team. So I was doing a bunch of different things there. I was doing like technical sales and design, a little bit of solar projects and lighting projects, doing cost estimates for how much those were going to be, putting proposal packages together to try to get people to buy those things, sitting down with them, kind of making the sales pitch to business owners, a little bit of homeowners. The homeowner was a tough business. The residential solar market wasn't great at the time, but so I got a lot of experience there, understanding how to design systems, understand how to price them out, understanding, what it is that gets people motivated to buy. And I did that for almost 3 years there in Michigan.
That's so interesting, because what you got as an experience there, those 3 years, is understanding the consumer side. Yeah, that's such very, very important knowledge. Like, some of the best people, whether they're entrepreneurs or they work for a company, they've had some sales experience, and that's something that you had for 3 years. Wow.
Yeah. I also got a lot of appreciation and exposure to the blue collar side of the industry. I mean, this is like guys out there and that wake up, have to be on site for 7 a.m. and put solar arrays in the ground. They're construction workers, they're electrical contractors, civil electrical work. And that's what it takes to do a project, right? It's like I can sit there and figure out what it costs and what it's going to save all day, but like you still need people to go out and build it, right? And I gained a big appreciation for that, and I think even understanding that side of it has helped me in my current role.
Makes sense. And so somewhere along that time, you went to China, right? Was it for a trip? Was it a renewable trip? What was it?
Yeah, so probably a good time to bring up Engineers for a Sustainable World, because that's what brought me to China. So Engineers for a Sustainable World, ESW, was a student organization that I was involved with at Penn State. I joined as kind of a fundraising chair. Then I was the vice president. Then I was the president. And then after I graduated from Penn State, I got involved in the ESW HQ, kind of the leadership organization for the nation. Really, they have some international chapters, but it's mostly in the U.S., right? So I got involved with them. I was the development director for a little while. And then I kind of phased out of that role, but I still was very interested in the energy education side of things. And actually, somebody that I was working with at ESW is how I kind of networked myself into my next job when I left Michigan and went to California, where I met you in LA, right?
Mhm.
So I found that role, moved to LA, and I was in LA, and that's when the China trip happened. I forget exactly what year that was. When I first met you, I had just gotten back from China, right? I think
Yeah,
that's what it was.
exactly. I think you were just in China a few
Yeah.
months, if not 1 month before.
Yeah. So what that trip was, we did this thing called was it called the Clean Energy Challenge, or no, it's called Community. Basically, the challenge was to get students to engage with their local communities, their city governments, their schools, whatever, and figure out what sustainability challenges the city was facing,
Mm-hmm.
kind of establish what the problem was, and then come up with a potential solution to that problem and present it. So write a little report and present it. So that was kind of the whole thing. So they invited me to be a judge for that competition for our partner group in China that was doing that. Right. So I got to go and be a judge for that competition for a couple days there. And then we spent another week or so after that traveling around China, seeing some of the sites, eating some really good food. You went to Chengdu. That's where you're from
Yeah,
originally,
exactly.
right?
That's why I remember, because you went to my hometown. I was like, wow.
Mm-hmm. Yeah, buddy, that was a lot of fun.
Wow. That makes sense. So what this means, so actually, let's first talk about, so in LA,
Yeah.
you had a different role than what you were doing in Michigan, right?
Yes.
Mhm.
So when I moved to LA, that was very similar to what I'm doing now. In fact, my boss then is still sort of my boss now, right? Shout out Steve Clark. If you ever see this, Steve's my guy. Love Steve. But yes, so that role was not square peg round hole. That was like, this is what I'm good at and this is what I'm doing, and it made sense, right? So that was like cost benefit analysis for energy projects. That was a big part of it, and that's like the main thing that I do now. So it was for energy efficiency projects, like lighting projects, to a lesser extent HVAC, heating, ventilation, air conditioning projects. So the state of California has all these public institutions, community colleges, for example. They're publicly funded, so therefore they're responsible to the taxpayer. So California puts these programs in place to set money aside so these schools can do energy projects, so they can invest in energy efficiency projects, right? So we helped them with all that, and then that kind of eventually turned into the solar side of that equation too, because it kind of fits under that same umbrella. You're spending some upfront money to save on your electricity bills in the long term, right? So that's what I was doing there, looking at basically helping public institutions, city governments, county governments, community colleges get energy projects done by figuring out how much they're going to cost, how much they're going to save, helping them procure it by putting together what they call an RFP package, or request for proposals. So we kind of spell out, hey, this is what we want. This is kind of where we want it. This is kind of what we're looking for. Give us your best price to do that. And then we evaluate all those bids and help them select the best contractor to come in and do that work. And then we help with things like contract negotiations, make sure that our customer, the community college in California, is getting a good deal and that they're getting what they paid for and everything works the way it's supposed to. It's called what they call owner's rep services. So the community college, they're good at what they do, but they don't necessarily have the expertise to pull off a solar project. They don't have anybody in-house that knows all that stuff. So they hire us on some sort of short-term contract to come in and help them manage that and get that across the finish line, right?
Oh, very interesting. And did the project get past finish line?
Yeah, I mean, several of them did. Not all of them do. Some of them, they just don't pencil, or some of them get bogged down. There's lack of funding or whatever. But many of them go through to completion and operation. Yes.
Wow. I mean, that would make sense, especially in California, where there's a big kind of emphasis on that stuff.
Yes.
Yeah.
California has that advantage where they put some different incentives in place to help. They also tend to pay higher electricity rates, so that makes solar make a little bit more sense. And they're generally pretty sunny too, so that doesn't hurt.
Especially Southern California, right? Lots of sun.
Yeah, and that's where we were too,
Yeah.
Mhm.
So this is a question that shows how little I know about solar power, but I distinctly remember in high school, I watched a documentary about how back then, so this is high school, so like in the early 2000s, it felt like one of the issues with, there seemed like two issues with solar power at the time. One was the wavelengths of light that you could use for generating the power in the first place was very limited back then. And the second thing was, of course, the battery storage. How do you store the power, right? So I assume both those issues have made lots of progress since I saw that documentary in high school.
Yes. So the first part you're talking about is you have so much solar power that's hitting, let's say, a roof surface, or a lot of what we do is parking lot canopies. So hitting some sort of parking lot, right? How do you convert that from solar power to electricity? That's kind of the challenge, right? So the efficiency of the modules, solar modules, has improved a lot. That's kind of what you're talking about with the wavelengths and band gaps, and you get into the kind of material science side of things, which is like I know enough about to speak to, but is not like my main area of expertise either. But that's improved, and more importantly than the efficiency, the cost has come down, right? So to buy, like they measure it in like per watt, right? So dollars per watt. So maybe when we, like, let's jump back to 2005, it might have been like $8 a watt for solar back then, right? Where that same solar now is like $2 a watt, right? So it's come down pretty significantly over that time period. So that's a huge factor. And that has a lot to just do with the manufacturing might that got thrown into the industry, particularly from places like China and other countries that really invested in, hey, the world wants solar modules, we're going to friggin' give them solar modules, you know, and they really cranked those out, and that brought the price down.
Yeah.
You know?
Yeah.
And then the second part of your question was
more the
about
storage of electricity.
storage.
And the reason I knew of this even in high school was that in China, they basically almost every house default came with a solar panel, but the storage was so bad that on a cloudy day, your water wasn't hot, right? So it was like, so a lot of places had to install a secondary, like gas type of heater on top of that.
Right. Yeah, so I can speak to that a little bit too. That's a big part of what we do now is the energy storage side of things. So in the States anyway, I don't want to speak to other countries, maybe they do a little differently, but in the States, most states have what they call a net metering policy. So what that basically describes is if you're going to put solar on your roof, it's going to be grid connected because you're already grid connected, your home's already grid connected. So when your solar produces, it's first going to feed your home's load. So if you're running your air conditioning or your lights or whatever, it's going to feed those first. But anything over is going to go back to the grid. So if you're producing more than you're using, it's going to feed it back to the grid, right? And you're going to be credited for those exports. Now, depending on what state you're in and what year it is, how much you're credited for that changes. In many states, you get what they call the full retail rate. Some states, they even give you more money. It's like a solar export thing that they just incentivize solar. They even give you more money, right? But anyway, you can export it to the grid. So let's say, yeah, you live in a state that's a pretty favorable net metering policy. You can export that at the full retail rate. There's really no reason to store it because you can basically sell it for what you were buying for anyway. And it's kind of like, it's, you know, $1 in, $1 out. It kind of nets out. That's why they call it net metering, right? And those credits, maybe they go on a monthly basis. So you have in the summer months, maybe you produce more than you use. So you have some credits and those credits apply forward to your future months. And then you drop from those credits in the winter when you're not getting quite as much sun, for example, right? And they set limits. So they say, okay, you can only size your solar array so big so it offsets your annual usage value to a certain percentage, maybe 100%, 110%, 90%, whatever the rules of that state dictate, right? So questions on that because California's gotten weirder since then. And for good reasons, but does that all make sense?
Yeah, that makes sense. It's like you want to incentivize people who obviously, especially if it's a sunny day, they're generating more power than they're requiring to give back to the system. And they're not just giving back without a reward, basically.
Yes.
So it kills two birds with one stone. It's like, okay, yes, you could store it or you could give it back to other people who need it. So that's really cool.
Yeah. So that's all fine and dandy. That all worked pretty well, right? But then in places like California, where they did such a good job investing in solar that they actually have so much solar during what they call the peak solar production window. So you can imagine, you know, your daytime hours, like 9 a.m. to 3 p.m., maybe 8 to 4, whatever, that's when your solar is going to be producing, right? So what's basically happened, if you just know anything about supply and demand, is they have an oversupply of electricity during the solar production window. Or maybe not oversupply, but certainly an abundance, right? So it's actually sort of forced them to adjust their net metering policy Do they no longer give full retail rate for exports? Right? They couldn't justify crediting people that full amount for any exports that they were sending back to the grid, so they had to use them. And then they changed it again where basically you almost get no credit now. You used to get like a little bit less, and now it's like, hey, you get whatever the market value is at the time, which is like not great, So that's where energy storage really comes into play, right? Because where you're talking about in rural villages in China, your energy storage and your solar is so you have power whenever you want it and need it, right? In the States, like we're connected to the grid, we have power for the most part whenever we want it and need it. But for economic reasons, in places like California, now you want to take all those exports that you would send back to the grid and get a diminished credit for it. And you want to be able to store as much as that as possible and use it later. Because what's happened is from 4 p.m. to let's say 9 p.m., all the supply demand curve flips because solar dwindles down. Now they have to turn on other power plants. So the prices of electricity during that window have gone way, 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 way up. So what you really want to do is store all your solar from this period and discharge your battery during this more expensive time period. So we help people figure all that out. We figure out, okay, how much solar can we put in here that makes sense without too many exports? What size battery can we put in here to move that from here to here? That's a big part of what we do.
I see. And then just for fun, what is the most OP'd battery? Like how long can an OP battery store solar power?
Yes. So good question. So we size them in what they call like a 2-hour solution or a 4-hour solution or even like a 6-hour solution. So all that's really saying is that's the ratio between, do you know the difference between power and energy? I can
Let me
explain
think about this. Yeah. If I remember high school physics, tell me, please. There's a formula. Okay. I forgot it.
Yeah. So power times time equals energy.
That's what it is. Yes.
So you could flip that upside down. You could say energy divided by time equals power.
Power. Okay? Yeah.
So basically a battery has both a power rating and an energy rating because it can discharge power. It can charge and discharge at a certain rate, right? So power is a lot like speed. So it's like, how fast am I driving right now? If we look at the odometer, I'm going 60 miles per hour, right? My solar module, my solar array on the roof is producing 60 kilowatts right now in this precise moment, based on the sun and whatever. You know what I'm saying? So a battery works the same way. It has a certain charging capacity. Let's say it's 100 kilowatts. Okay. It can charge and discharge at that. But then its energy capacity is 400 kilowatt hours. So that means it's a 4-hour solution. So basically, if I were to discharge that battery at full capacity, it would last for 4 hours. If I discharge it at half capacity, it would last for 8 hours.
8 hours.
If I discharge it at quarter capacity, it would last for 16 hours. So that's kind of how we size them, right? So with your typical lithium ion batteries, which is like what we're usually putting in these cases, right? They're really good at scales like that. They're really good at turning on and off really quickly, responding to loads very quickly on the sub-second level, right? They're pretty good at these couple hours worth of power, being able to change pretty rapidly, right? What they're not as good at is what they call like deep energy storage for like multiple days of energy storage. You obviously can recharge it the next day when solar comes back, but there's other kinds of energy storage, like for example, pumped hydro. You know anything about pumped hydro? So hydropower works by flowing water downhill, and that water spins a turbine, and that spins a generator, and that generator makes electricity, right? Well, what you can do is you can just pump that water back uphill. Right? You put energy back in by pumping the water and put it back uphill to some sort of reservoir, store that water in that reservoir, and then when you need the electricity again, you just release some of the water. So that's those sorts of things I'm really interested in too, like deeper energy storage. If you need multiple days, now that's not going to cycle as quickly as a battery. You're not going to be able to get that instantaneous response in that same way, but you can provide energy on a longer time horizon, probably, right?
Yeah. And essential assumption is that the energy it takes to pump the water back is so minuscule that, storing it and having it be able to make the energy is way worth it, basically.
Yeah. So you're going to have, from thermodynamics, like nothing is 100% efficient, right? Or it can't be more than 100% efficient anyway, right?
Yeah.
So let's say pumping it, you lose 5% of the energy or whatever, right? And then you get 95% going up and you get 95% going back down. So you have a round trip efficiency there of 95% times 95%, which is like basically 90%. So you're losing 10% of your energy, right? You don't lose it, but you don't get the capture.
Yeah, exactly.
Cash in on it, right? But if the cost difference there is significant enough, it's worth the exchange, sort of, because
Yeah.
it's more valuable at that point when you're going to use it than when you're storing it, right? They call it's just like the stock market. You buy low and you sell high. You pump the water up, or you charge your battery when energy's cheap, and then you discharge it when energy's expensive.
Yeah. Follow the market, right? Market rates,
Exactly.
as you say.
Mm-hmm. Yeah, buy low, sell high.
Yeah. So then a natural segue is, okay, so we know this is your area. You're passionate about it. What's the day in the life now for you?
Yeah, so I got back into doing a very similar thing that I did then, right? So there was a bit of a transition here. So I do want to answer your question, but I want to wind it to where we're at today, right? So where I was in California, what I was doing then is very similar to what I'm doing now. But then in 2019, I left that job to go through hike the Appalachian Trail. So that was kind of like a personal detour that I did for myself. Nothing related to professional development or anything like that. It's just like a soul journey, you know? And then when that wrapped, I was kind of looking for my next opportunity, which led me to teaching a solar energy technology program at a public high school in Philadelphia. And I did that for 3 years, from 2020 through 2023. And we can talk about that here in a second too. But then after that, I reunited with my old boss, where I was working with him in California. And now we're doing very similar things that we were doing then, but a little bit more advanced. I'm not doing kind of like the lighting and the HVAC projects anymore, although sometimes we'll evaluate some of those things. But mostly what I do now is the solar and energy storage side of things. And then we're also getting more and more into electric vehicle fleet conversion and planning.
Oh.
So you're dealing with a city or a county government, for example. They have X number of vehicles. Let's say they have 1,000 vehicles and they're all run off gasoline or diesel or whatever. But they want, or they're incentivized to, or they're mandated to by the government to replace those vehicles with electric vehicles to reduce emissions and costs and everything else, right? Mm-hmm. So we're helping county governments figure all that out. Okay. What vehicles to replace when? Okay, you got 1,000 vehicles. We're not going to replace all 1,000 of them overnight. Let's scale it out. Let's do 100 a year for the next 10 years. Okay. Which vehicles can we replace immediately? Like, which vehicle has an adequate replacement on the market that's at a good price point that we can actually go buy it right now? And then which vehicles maybe we don't have a perfect solution for, that we have to kind of wait a little while until the market catches up, or until whatever, you know? So we're helping them figure all that out too. So I spend a lot of my days in spreadsheets doing math problems, like basically like complex word problems around energy projects, right? And then communication, right? So like figuring out what even the problem is in the first place, like talking to the stakeholders, figuring out what is it that they even want to do. What is it that's holding them back from doing that? Like, what are their goals? Like, what's driving them forward? Figuring all that out so I can even set the parameters of the word problem to begin with, right? Then I go and I solve the word problem. I work with my boss, Steve, to kind of like, he makes sure that I'm not crazy. You know, I'm like, okay, this makes sense, right? And I did this and I did this, and that's why this is this way. And, he's like, you know, we go a little back and forth there. And then eventually we have to communicate that to who hired us, so they can, and we have to be able to put that in layman's terms, because not everybody knows the difference in power and energy, and they don't want to know. They just want to know, should I buy this thing or should I not buy this thing? So we have to kind of bring it all down to like actionable next steps. Okay, what should we do? How big should we go? How many vehicles should we replace? How much solar should we do? Right? That sort of thing. So we have to explain all that, because we're dealing with public sector entities. It's not like they're the CEO of a company that can just make the decision. They actually have to go in front of a school board or the county commissioners meeting and make the argument or state the case, present the numbers, and get the support to move forward with that. So that we have to kind of inform that decision making.
Yeah. Wow. So I mean, it sounds fun. Yes, working spreadsheets, sometimes it's like, oh, my eyes, I gotta take a break. But it sounds fun. It's like you're really the issue is, right? There is a little bit from layman to the expert, there is a
Yes.
little bit of a learning curve. So it's like people like you are basically like, okay, let me just make you not afraid of the learning curve. I'll break it down for you.
Exactly. We have to kind of hold their hand a little bit, meet them where they're at, make sure they understand what they need to understand, make sure that they have confidence to move forward, because they just don't know, and you gotta show them the numbers so that at least they know.
Yeah. Yeah, exactly. Now, from your experience, and we can definitely pull in the teaching stuff too,
Yeah.
is the general public more on board with this stuff now, more on board with solar? Or maybe that's too broad a question because it might depend on the region and stuff like that. But, compared to, let's say, when you were in high school versus when you taught high school, are like when you mention solar power, do people have like one or two facts, or are they completely in the dark still about it?
Yeah, I mean, if you look at the growth of the industry since 2005, when I was just a high school kid talking about this stuff, right? It's crazy. It's been exponential growth in this industry. So more and more people know about it, are familiar with it. And people will say, "Oh yeah, my so and so, my cousin has solar on his roof or something," or "Yeah, oh yeah, my uncle drives an electric car." Like, you have that touch points for people. Like, it's not necessarily like a household name exactly, but it's like you're familiar with it. Most
That makes sense.
generally speaking, most people are like, "Oh, I know what you're talking about."
Yeah, yeah, that makes sense. So, yeah, that's encouraging, and it's also like I'm excited where it's going to go, especially as some of, let's say, those students you taught in high school become their future engineers and stuff like that.
Yes.
Yeah. So,
And I
yeah,
still
let's
keep in
briefly
touch with a
talk
few of
about
them.
the yeah,
Yeah, I
let's
still keep in
let's talk
touch with
about
a
the
few of
game.
them too, and it's good to see that they're getting after it.
Oh, good.
Yeah.
So that meant you brought your passion and you communicated it to at least a few of them.
Yeah, man. So that job was crazy. So, like, it was kind of, when I first got that job, it was like right when the pandemic was happening, right? It was like early 2020. I was applying for jobs or whatever, and I ended up seeing this solar energy technology teacher position. I'm like, what? This exists? It's like, this is awesome. Like, this has my name written all over it. Like, this is perfect for me. And I applied and everything, interviewed, and they actually didn't offer me the position at first. And I was actually kind of sad. Like, it was like my birthday, and I remember like being like let down that I did not get this position. But I did all the things you're supposed to do. I sent a follow up, and I was like, thank you for taking the time. Hope everything works out great. I'm excited that y'all are doing this. And like, if anything changes and you need me, like, reach out, and happy to reconnect and see how things go. And like, sure enough, he emails me back the next day. He's like, actually, like, let's talk. Because like, whatever, it fell through with the other person, and then I was like, I'll take it. I was into it. So, but that was a challenge because I came in with kind of high expectations, and to some extent, I was maybe a square peg in a round hole there too. I came in with like this energy engineering background, cost benefit analysis, reports and that side of things. And they were really trying to gear this. They didn't want to say the quiet part out loud, but it was mostly to get students as installers.
Oh, so more like
Solar
almost like
installers.
trade school. Yeah, like yeah.
Yes. It was leaning that way heavily, and that was like not my strongest. I had experience doing that. Like, I've installed some. I was on construction sites, but I wasn't physically the one out there nuts and bolts turning wrenches either.
Yeah.
So that was hard, but I was able to pick it up as much as I could. I worked in the summers on a residential install crew to get some of that experience, to build
Wow.
those skills, to be able to deliver that side of the content a little bit better. And that helped a lot, right? But I also came in with these expectations that, hey, these students that signed up for this, they must love the environment. They must be so passionate about sustainability, and they're probably like so eager to learn about this. And it was like, they didn't even know why they signed up. They like just fell into it. So it was kind of like, oh, dang. So like, it took a little bit of like an ego hit there, and I had to reset it and be like, okay, well, it doesn't matter. At the end of the day, I got to meet these students where they're at.
Yeah.
If they don't care about it yet, I got to get them to realize that this is a potential path forward for them, that they can, develop a career for themselves. They can have an identity in this community that's working on these things. They can have a positive impact on their community and their environment and all those things. And like, I think I was able to package that up in a way and deliver that to those students.
And I'll back it up slightly. So
Yeah.
how did you manage to just in the summertime just work with those like installation crews? Was that provided by the school, or is that something you found on the side?
Yeah, so it was kind of like a partner organization for the program because they were already doing their own solar energy education coursework thing on the side, but this was like a new addition to that, which was with the Frankfurt High School School District of Philadelphia. So they're called Solar States. Shout out Micah Goldmarkle, also a great dude. I admire that man a lot. He's like the president and founder of that Solar States company there in Philly. So they do residential solar. I think they do commercial solar too, but they also they have an arm that is focused on solar energy education, getting students trained up for installation, young people, high school, maybe right after high school, previously incarcerated folks. They have programs for those kinds of people too. It's like, they're doing good work over there, and I have a lot of respect and admiration for them. So yeah, so I linked up with them because they basically knew I was pretty open. I was like, because there was like 10 things I had to be good at coming in and teach this fun. And I was like, I'm good at this, I'm good at this, I'm great at this, I'm great at this, I'm the best in the world at this. But like these 3 things, not so much. I'm gonna need some help. You know what I mean? And I was honest about that. And they understood, and they got me trained up as best as they could to do those things,
Mm-hmm. Yeah. I see. So those 3 years, did your teaching style evolve those 3 years?
Yeah. So the first year was like primarily on Zoom because it was the pandemic thing. So that was just really tough, right? Because, imagine we're having this conversation, but I turn my camera off, right? I turn my microphone off. I'm not super responsive. I'm texting. I'm playing video games. Like, how engaging could it possibly be, right? So that was really tough, and it took a lot of like I got depressed because I'm like dumping my heart and soul into this screen, and I'm not getting barely anything back, So that was tough. But then once we got in person in the real world in the school the following year, it changed because then I was myself. I was able to earn the respect of the students. I was training jiu-jitsu at the time, so like they knew I was like no pushover. They weren't going to come in there and bully me, like it's a tough school, they're tough kids, you know what I mean? I was able to it's like, you're not running the show here, boys and girls, I'm in charge here, and this is how we're going to do things, and I try to teach them a lot of other things too about philosophy. Like I've talked to you about like the Hogwarts houses, right? And like how to build that into your character, right? And then so that helped a lot, just like not just hitting them with facts, but like, hey, this is like life, and this is like why it matters, and this is how it works, and this is why it works, right? And I think that went a long way.
And what made you decide to take the break on the teaching and go back to the industry itself?
Yeah, that's it. I think I kind of I was just like, I got to a point where I was like, I think I'm kind of good on this. There was some, what do you call it, administrative things in the school that were kind of rubbing me the wrong way. There was a lot of rules and regulations and just kind of like things that didn't really seem to matter, that they were blowing out of proportion, that like seemed like they mattered a lot. Like calling home every week to the students. And it's like, I don't want to call home. The parents don't want to talk to me. I don't really want to talk to them. Like, if their students aren't showing up, like, what am I supposed to do? Like, I can't go to their house and drag them here. It's like, if they're here, when they show up in class, like I'm full, my heart is here, and they're going to get everything they have out of me. But there was just like a lot of extra stuff that they wanted that I was just like, why are we bothering with this? I kind of got like a little annoyed and frustrated with that, to be honest. And that's kind of on me. I probably could have done a better job. But also I kind of realized like, I had a good run here. I had a good 3 years here. I could probably get back into what I was doing previously and probably make a little bit more money at the same time, which is exactly what happened.
Yeah, that makes sense.
Yeah.
So, you're mostly in the Pennsylvania. Do you cater towards the whole tri-state area or just Pennsylvania?
With my work presently?
Uh-huh.
Yeah. So, most of my team is actually in California. So I work on like an 8-9 person team, a small team. And we're a big company. I work for Accenture. They're kind of a bigger company, but my team's kind of small, and half of them are in California, more than half. Some of them are in the Pacific Northwest, and I'm really the only person on my team that's out here. But like most of my clients that I deal with are in California. Public sector entities in California, community colleges, county governments, city governments, transit agencies, that sort of thing. Now we
Yeah.
do other stuff for other places, but 80% of my work is in California.
Yeah, that makes sense. That makes
Yeah.
sense, though.
Yeah.
You must have a interesting schedule because sometimes you have to wake up at a different time to meet with some people.
Yeah, so I call it the East Coast advantage when it comes to work. At least if you don't mind working late sometimes, because
Yeah.
like if I have a meeting before 10 a.m., it's very rare
Hmm.
because most of the people I'm in are 3 hours behind in California
Yeah.
from the East Coast, right? But then it's not uncommon for me to have meetings at 5, 6, 7 o'clock sometimes too, and you just kind of got to roll with it. I don't complain. It kind of works out good.
Yeah.
I like being able to get up early and get stuff done without being pinged on Teams, get asked questions without, gives me time to get some things done. And then I'm always ready for my meetings in the afternoon and present whatever I did. And it works out pretty well.
Yeah,
It's not
exactly.
as good as though when we used to go watch the UFC fights in California and be home by 10 o'clock at night. I missed that. I don't
Oh,
quite
yeah.
get to do that here in good old Pennsylvania.
I did a UFC fight night kind of reaction,
Yeah.
and it ended at like 1 or 2. I was like, oh, man.
Yeah, it's tough.
Yeah, it's tough.
Yeah.
Yeah, that's another conversation for another time. But yeah, we should
Yes.
talk about that too. It's like, why don't they have it earlier so the East Coast people don't, completely lose their sleep?
All about the Benjamins, baby.
Yeah. Wow. So what are some projects you're working on to the extent that you can talk about them right now that you're really excited about?
Yeah. So, I probably shouldn't name specifics, but I can say that basically looking at procuring solar energy storage and electric vehicle charging stations, right? So I have a couple projects right now that are looking at that. So right sizing them, figuring out what's the appropriate size here that gives us the most bang for the buck, a good cost benefit ratio there for ourselves. And then figuring out, okay, how big of a battery pairs with that. It's kind of a similar kind of a math that we have to do to figure out how much of this solar exports can we not export? Can we put in the battery and bring? And then we do this other thing called peak shaving. It gets a little technical, but basically your build for not only how much energy you use, but it's almost like getting a speeding ticket all the time, right? Imagine not only do you pay for the gasoline to travel from A to B, but you also pay a second fee for how fast you drove, like the peak speed that you drove. So if you did 100 miles per hour on the highway, you got to pay for that too. Versus if you took back roads and did 35 the whole way, you pay a different rate. Okay. So we use batteries to bring those costs down too, right? And then figuring out how many charging stations to put in based off their fleet conversion plan, like developing that fleet conversion plan, right? Yeah, it's good. That's a lot of what I'm spending my time with too. And then I'm also getting more into the energy education side of things too with Accenture. So they're trying to kind of basically self-educate their employees on these topics. So I'm working to develop some, or more like modify the existing coursework to improve those things, to make them more interactive, to make them more interesting, to make them more relevant, to make them simpler. What do you really need to know here? What skills are transferable to other things? So I'm excited about that too.
That makes sense.
Yeah.
So what are some trends in the industry / where do you see both yourself and the industry in like 5 or 10 years or 20 years?
Yeah. So in terms of trends in the industry, a big issue that we're dealing with right now is the current administration is just not super pro renewable energy. And we're dealing with that. There's some pending legislation moving through the House and Senate right now that could have a pretty significant impact on the cost benefit of solar projects and energy storage and perhaps electric vehicles as well. So that's just a challenge because people don't exactly know what's going to happen as things are in flux. Like nobody wants to make a decision when things are in flux, right? Because you don't know how it's going to land. So that's creating a lot of stress for our clients, right? So we'll see how that shakes out, either just on the short term over the next 6 months, but also the next election cycle. Like I know some people have the luxury of where their jobs are not quite impacted by politics. Unfortunately, I do not have one of those jobs. Like sometimes you get somebody in there and it's like we're going to do all these solar incentives. And it's like, go. And it's like, I have all this work to do and everybody wants to do a project. And someone's like, and sometimes you get the opposite where, hey, we want to take away the solar incentives. And it's like, okay, well, that means everything's going to slow down. That means we got to be more selective on the projects that we can do. So I feel like we had to talk about that because that's on everybody's mind right now. That's in the solar and energy storage and electric vehicle industry right now, is dealing with that and dealing with the uncertainty, not knowing how exactly it's going to unfold.
Yeah, exactly. So yeah, it's interesting. I never thought about this, but both my parents, since their companies somehow involve federal government, so they are very, until this administration, they didn't even realize how election dependent they are, right? But the solar industry would be a very election dependent industry too.
Yeah.
Wow. So
yeah.
That being said, I'm happy that despite certain uncertainties, the knowledge and the general development of the infrastructures, evolved a lot since we were in high school. So that's good.
Yeah. Yeah. There's been a good investment in it. It's been mostly bipartisan too. I mean, I think the major incentive for solar is what they call the investment tax credit. They call it the ITC for short. I'm pretty sure that was put in by Bush Jr. So that's like goes back to 2000 something, right?
Wow.
And then it was continued by Obama and whatever. And the current guy doesn't seem to be such a fan of it, but that's okay. That's all right.
Which country or maybe countries are the most like solar evolved or solar friendly?
Yeah, good question. So I think the US and China, I think, are 1 and 2. You'd have to look up and confirm which one's 1 and which one's 2, because China just goes hard. They go hard in the paint. When they decide they want to do something, they just like throw everything at it. So they're like, I think they're number 1 in wind. I think they're number 1 in solar. They just go big, they're number 1 in hydro, all this stuff. I heard they built a hydro project recently that like changed it's so massive that the mass of it has actually changed the rotation speed of the Earth. Like by some minute fraction of a second or whatever, but that's like how big that project is, right?
Wow.
But then you have other countries like Germany got really into it, decades ago, and they did a lot of solar, and they're not even like the sunniest place in the world either, but they did a lot. Yeah.
I remember one of the first.
A lot of people are getting in the game because they know that it's going to be at least part of the future. Whether you want to say solar is the future, but is maybe too extreme, but certainly a big part of the future of electricity and energy in the world.
Yeah, I think this was college. So after I saw that documentary I mentioned to you, the second time I thought about solar was in college. I remember I was listening to a talk or something like that, and they mentioned that in the Autobahn, the big German highway system that inspired our interstate highway system for good or for bad, the Autobahn has segments where it's like just solar panels lining it. And so that's how they were getting their solar. Something like at that point, it was something, again, don't quote me on this for anyone watching, but I think when I was in college, I think 20% of their power was already solar. It was 20 or 40. It's probably 20. I probably wasn't 40, but it was like, it was a number that made me go, whoa. I didn't know Germany, just like Jordan said, I didn't know Germany. I didn't think it was a sunny place, but they're getting a lot of power from solar. Could have been 10, 20, or 40. One of those. Pick one.
Yeah. And then you have other countries like Iceland and Costa Rica, I think, is another one where they get almost 100% of their electricity from renewable energy sources. Now, they happen to be rich in those sources. Like, for example, Iceland, they're big on the geothermal. They have a great underground heating source from just, the Earth's natural heat, right, from being close to the mantle or whatever. And then Costa Rica, I think they have a lot of different things, wind and solar and hydro and whatever else too. So sometimes it just depends on what resources are available to your country.
Yeah. And I had to look this up too. So what Jordan was talking about earlier about that humongous project in China, it was the only project that even like within the government, which usually puts on a united front, there was a little bit of like differing views. Like people expressed it because it was such a big undertaking. And it's China's biggest river. Basically, it's the Three Gorges Dam.
Yeah.
And I had the luxury, thank goodness, I had the blessing of taking a cruise on it right before it was going to get filled up. Yeah. So a year before the dam was finished, I took a cruise on it. And so I got to see the last remnants of all the historical environmental stuff. You know, now all that stuff is a reservoir and stuff like that. And there's quite a lot of people who argue. Again, this is one of those things I'm only passing along. So I'm not the expert, but
Sure.
apparently some of the increase in seismic activities, especially in places like Chengdu and stuff, is because of that dam. If it can change the rotation of the earth by a little bit, I'm sure it can create seismic activities too. It's a lot of pressure, a lot of water.
Yeah, yeah. And you know, renewable energy sits in this weird spot where typically the people that are doing these projects, like they don't want to have a negative impact on the environment. I mean, most people don't want to have a negative impact on the environment, but these people are, you know, even more conscious of that. So they have to be extra careful, right? So like hydropower, that can have negative impacts on the environment. Like you're flooding whole regions out and you're changing landscapes by doing those things. Or like wind projects, right? So like what impact is it having on bird migration or on bats, right? Or when they put them in the ocean, what impact are they having on whale migration, right? Like those things are real concerns. Like, and that's not my area of expertise. I'm not going to sit here and tell you that that's fake news or it's real or whatever. It's not really, I don't know. Y'all can look it up and leave your comments, you know, but yeah, we certainly don't want to have negative impacts, or at least we want to minimize those as much as possible.
Yeah, exactly. This actually good little topic. I never thought about it because I don't think personally solar has any negative impacts. Does it? Does solar have any potential negative impacts?
Well, it's a good question. I'd like to say no, and I'd say probably pretty minimal, but you know, the resources are mined. You're mining the materials to build those out. You're mining the materials that go into the batteries, for example, right? That has an environmental impact. That's a social impact.
Yeah.
You have the recycling associated with these things. Like some of them, there might be issues there. I'd say it's pretty minimal, but there's always some impact, right?
Yeah.
Particularly for like the bigger projects. If you're going to think you're going to go do a massive project in the desert somewhere and have zero impact on the environment, seems unlikely. You're going to have some sort of impact, right? But they, you know, they set aside a budget and they bring in the environmental engineers and they do the ecosystem impact studies and they make the adjustments to minimize that as much as possible. And I think that's money well spent.
Yeah, exactly. So, last question for you, Jordan. And again, awesome talk, great talk. What is next for you? Well, obviously you're going to keep working in this. Any other plans? Any other, you know, you said you're maybe going into education a little bit on the side. What other things you got planned?
Yeah, I'd like to be able to just continue into this role. I'm almost at the 2-year mark in this specific role. I'd love to really grow into it. There's some changes in the company that are happening. I'd love to take on more of a leadership role in this regard. I feel like there's parts of this that I'm like pretty good at, and I'd love to be able to have more of an impact for our clients. So, you know, no major changes in terms of direction, just more like maybe more of the same and the bigger impact and potential leadership role. And then, yes, you brought up the energy education side of it too. I'd love to be able to spend more of my time talking with people who want to learn more about this. I feel like I can explain it reasonably well. I think I can do it in a fun and engaging way. It's fun for me too, to kind of engage with people and ask them questions and kind of work together, just like when I was teaching. So trying to do more of that, I'm excited about too. And then the last part is like, I'm pretty good at the solar and energy storage side of things, but like the the electric vehicles and the fleet conversion planning, like I'm just getting into that. There's a lot to learn there about what vehicles are available, the price points of those vehicles, which ones can be swapped for which ones, like how to do this intelligently, right? So that's something that I think we're going to get more and more involved in, and I think my expertise is going to really, really grow in that area.
Yeah, I'm super excited for that. And when you get really into that, maybe in a few months or something, let's do another talk. The reason is because the word on the street is China's pretty good with its EVs, and we haven't seen their EVs in America, but apparently like in China, those EVs are really good. Now, I can understand why Chinese cities would embrace EVs because cities, the distance between cities are much smaller. Like because China's got so many people, you might have a 1 million person city that's 1 1 hour away from a 3 million person city. That's then another hour away from a 6 million person city, right? It's not like America, where like America probably only has like 20 cities that have over a million people. China has probably like hundreds of cities over a million people.
And they're much more densely populated too.
Yeah.
So you like, you know, there's benefits of EVs for per mile, right? But like a big benefit comes from the idling.
Yes.
So if you're just idling your gas powered vehicle in the city and it's just like that's just wasted emissions basically, you know, just like unnecessarily. But if you replace that with an EV, that EV does not idle in that way.
Yeah.
So like, you know, all those localized emissions that create the smog and that local pollution, that's like, you've been in cities like that, it's like nasty, like LA. But like, you know, Beijing and other places, it's like pretty nasty, dude. And nobody wants that. That's, you know, even if like things like climate change are a hoax, blah, 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 which I don't think that's true. There's no denying that those local emissions are pretty toxic and not fun for anybody involved. So being able to remove much of that by replacing those with electric solutions is a good move.
Yeah, exactly. So yeah, I think let's bring you back when you really delve into the EVs, because I'm sure there would be so many insights. And one day, maybe somehow America and China can have a slightly better relationship, that we can like exchange more technology again. Again, I'm probably wishful thinking it, but yeah, I think it's better if two countries with very smart minds can work together. But you know, I'm not the policymaker here.
Yeah. We'll figure it out, right?
Yeah,
One way or the
exactly.
other.
Exactly. Guys, this was Jordan Crolly, and very, very intelligent guy, very passionate guy, and we'll have him back soon.
Thanks, Jerry. I appreciate you, my friend.
Absolutely.
Take care.